All right, so let's do a quick review over circuits in series. Here we have a circuit. That little yellow part right here, that is your battery or your power source. That usually gives you the voltage that is running through the circuit. And these three are resistors, R1, R2, and R3. Now, when they're beside each other like this or on the same wire, we say that this circuit has resistors in series. The total resistance is going to be equal to R1 plus R2 plus R3. So whatever they give you for those three resistors, you just need to add them up to get the total resistance. And then after that, the V equals IR rules come into play, and you can find either voltage or current using the total resistance. The voltage changes through each resistor. So once you find the current using total resistance, you use the fact that voltage is equal to current times resistance to get the voltage in each one. Current is constant through each resistor, so you don't have to worry about finding different currents. When circuits are in series, the voltage is what changes through each resistor. The current is going to remain constant. Now, today we're going to take a deeper look into circuits in parallel. Now, circuits, the resistors are in parallel if you see them basically set up like rungs on a ladder. So you'll notice that each of these resistors are on a different wire, but the wire is kind of split up to get to each resistor. And we have this point here and this point here where they split up, and then we get to our third resistor. Now, when we have resistors in parallel, the way we get the equivalent resistance or the total resistance is 1 over R total is going to be equal to 1 over R1 plus 1 over R2 plus 1 over R3. Now, we get to use calculators, so what we're going to do is we're just going to put the fractions in the calculator and add them up. And then whatever you get, you're going to put 1 over that number to get RT by itself, because this gives you 1 over RT. Voltage is constant through each resistor, so the voltage source here is going to be the same voltage as what's going through R1, R2, and R3. With this being said, current is the one that changes for each resistor. And the way you're going to find current for each resistor is you're going to use V equals IR again. So here's an example of a problem that I would give you for a circuit with resistors in parallel. If the length of wire is cut into 5 equal pieces, we're assuming that we're going to have 1, 2, 3, 4, 5 rungs, and that each of these is considered a resistor. And then we have our power source here. The resulting resistance is 2 ohms. What is the resistance of the original length of wire before it was cut up? So 1 over the 2 ohms, that's your R total, is going to be equal to 1 over R plus 1 over R plus 1 over R plus 1 over R plus another 1 over R. So you have 1 over R 5 times. So basically 1 over 2 is equal to 1 plus 1 plus 1 plus 1 plus 1 is 5 over R. Now, once we cross multiply, we get R equals 10. So R is 10 ohms. So that means that each one of these resistors is 10 ohms, right? Now, the original length of wire before it was cut up, if we added all these together, 10 plus 10 plus 10 plus 10 plus 10, that would actually be 50 ohms. Because each of these are 10. If they were in series, if they were all in one line, 1, 2, 3, 4, 5, it'll be 10 plus 10 plus 10 plus 10 plus 10. A 4 ohm resistor, an 8 ohm resistor, and a 12 ohm resistor are connected in parallel across a 24 volt battery. First thing they want us to find is R total. Now the way we're going to get R total is 1 over RT equals 1 over 4 plus 1 over 8 plus 1 over 12. So as we do this in the calculator, we now have 1 over RT equals 0.4583 repeated. 3 keeps going on and on. So remember, this is 1 over RT. So to flip this, you're going to do 1 over that number, or you can put it to the negative 1. Which gives me 2.18. So, what is the current in each resistor? Well, we have our total, which is 2.18. Do we need that? Not really. I is equal to V over R. So you have 24 divided by 4 for R1. Because that's V over R. 24 divided by 4 is 6. For R2, we have 24 divided by 8. 24 divided by 8 is 3. So that's R2. And then for the third one, we have 24 divided by 12, which is 2. And that is the current going through each resistor.